Hello and what is up everyone and welcome back to another video on the YouTube channel. In this video and episode we will be talking about classes versus objects. So if you haven't been following along, be sure to follow along. The previous three episodes talk about, what are different types of data types and some basic variables, as long as some basic operations you need to know in Java before you progress any further. So if you haven't already, be sure to watch those videos first and then come back to this one. But without further ado, let's get straight into the video. If you're new here, please subscribe to the channel. It'll mean a lot to me. Also, share this video with your friends or anyone else who needs help with programming in Java. I might be able to teach a thing or two. So let's get into it. What exactly is a class? A class is a template for objects. A class defines properties, including a valid range of values and a default value. So, for example, let's suppose that you want to write a class representing all the students in your high school. Why would you do this? The reason you would do this is because the student class would serve as the basic templates for all student objects. You want to have a framework for creating each student, if that makes sense. For example, you know for a fact each student has a name. Each student also probably has a GPA, and they probably have some sort of grade. But each student's name won't be the same, their GPA won't be the same, and their grade won't be the same. So they have shared characteristics, but the values of those aren't exactly the same. And that's the whole point of blueprints and templates. The whole point of templates and blueprints is for you to have some basic layout, which you can then fill out and personalize to yourself. That is exactly what an object is. It takes a basic layout of a class and it just personalizes a bit more. For example, it'll give a value to the name, it'll give a value to the GPA, and it'll give a value to the grade. And the reason why we don't define these values hard set in stone in the class as we see over here is because these values can change depending on what student you are. For example, every student has a different name, every student has a different GPA, and every student has a different grade. But it's worth to write these down because you all know they have this characteristic. It's just that the values are different. So we'll go ahead and assign those later, but let's at least make sure that they have the same characteristic. That's the whole first step, what we do in creating a class. We create the instance fields, as you can see here. So essentially, the instance fields are the common characteristics all the objects of a class would have. So as I mentioned with students, it's name, GPA, and grade. Now that we have the first step out of the way, the second step is to create a constructor, as you can see here. Now, the way constructors work is that it's actually a special function of a class. Now, if you recall, a function basically takes an input, it does something to it, and it produces an output. Now, what does a constructor do? A constructor allows you to create an object of the class. So, for example, we have the student framework. We know exactly, okay, we know the framework of a student. We know what his name, GPA, and grade, and so forth. How do we go about creating the student? We do so using this method called a constructor. Now, what are these parameters that you see here? That might confuse you a bit. Why do we have name 1, GPA 1? Why are there duplicates of the lines over here? Now, these are the parameters that you assign to the constructor. Because as you can see here, when we create an object in line 33 and 34, we're giving in values to the method over here. And then what we do with those values is that we store them to the instance fields here, which we can refer to later in the class if we were to create other supplemental methods. So the purpose of the constructor is to create the object. We need some sort of values to create the object with, and then we go ahead and we initialize all the variables over here in the constructor. So we'll assign, for example, let's look at line 33 where we created the object. I'll go over how to create the object in a bit, but let's just suppose we have this object Paul created, which is a student, by the way. We pass in the argument of the name, which corresponds to here, as Paul. And that gets stored in this name1 variable, which in turn gets stored in name. When you're basically initializing this variable here, 3.83 is the GPA. You're storing that in GPA1, and GPA1 gets stored in GPA. And you have junior, which gets stored in grade 1, which then gets stored in grade. Now, you may ask, why don't you just store this, directly over here? Well, and why are you doing a duplicate? Well, this is the way to store it. We can't just assign Paul to like name because we don't have because the variables are defined above the constructor. That means that the entire class has access to it. Whereas if we define the variables inside the constructor, only the stuff inside this area would have access to it. Hence, we define it above the constructor, so everyone has access to it. But in order to define these variables when creating the object, we pass values in these parentheses, and we have these transition variables we use to temporarily store the values, but then we assign them to these values over the variables over here. Hopefully that makes a little bit of sense. Now, how do we create the object? We create the object in a main method or entirely separate class. That's where we create the object. Whenever we create objects, always make them in the main method or create a new class and have that class have a main method and then create the object. Because the main method is kind of where you run and execute your code. The class is where you build the code, and the main method is where you just, execute it. So how do we do it? First, we say the type of object we're creating. We're creating a student. And that's one important thing that I forgot to mention is when you create a constructor, you have to say public and then the name of the file, which in this case is student, and the name of the class, which is student. Because you're kind of creating a type of the class, so it would make sense that your constructor is named, which is so it makes sense which your constructor, which is the type of object you're creating, should be the same name as the name of the class. So you're doing student, because that's the type of object you're creating. Let's give this a variable name as always. And then what we're going to do is we're going to go ahead and use the keyword new, and we're going to create a new student with these arguments to pass into the constructor over here. Remember, Paul corresponds to name 1, 3.83 GPA 1, junior grade 1. Now, this might sound a bit confusing to you, this form of declaring a variable, so I'm going to go ahead and simplify. Let's suppose we create a number. If we create the number 5.85, right, we have a type, which is basically a double, which is a primitive data type, not a class. But this is kind of like, a type, except it's an object. We have the name of the variable, we have the equals to or assignment operator in both cases, and we have the value. In this case, this corresponds to our value. We're creating a new student with the following values and assigning them to these characteristics. So one last thing to note is that when we create objects, when we create instance fields, we can also refer to the variables, to the values of the variables here. So for example, when we say system.out.println paul.gpa, what we're essentially doing is we're printing the GPA of Paul by accessing this GPA variable over here. Now, GPA, it's not defined to 3.83. How does it get an assignment? Well, when we created the object Paul, we automatically passes a parameter argument for 3.83 for because it was required here as a GPA. That 3.83 got assigned to the variable GPA 1, which in turn got assigned to GPA. And when we access GPA, we're going to get 3.83 because it's stored like that. Now you may ask yourself, well, okay, we just created a new student, Bob, whose GPA is 3.73. So by that logic, GPA 1 is down 3.73. GPA 1 gets assigned to GPA. So wouldn't the value of GPA now be 3.73? And it would also change for Paul as well, right? Because, a variable can only store one value. But these are two different objects. So they basically have their own copies for each. They have their own string name, their own double GPA, and their own string grade. Since they're two separate objects, we don't have to worry about overlap. Think of it as a template. So if we run this code, okay, give me a sec. There's a reason why it didn't work, and let me fix that right now. So with Replit, if you're using it, you have to manually compile the file and manually execute it. Otherwise, it's just going to run main.java. Just giving you a heads up. See, it printed 3.83 and 3.73 from the same variable, but the object is different. Because the object is different, the variables are basically copies of each other, but they're different because they belong to different objects. Hopefully that makes a little bit of sense. Next episode, we'll talk a little bit more about, adding helpful functions to each class, and then instead of accessing variables, accessing those functions. I hope you took something away from this episode. Please give me any feedback if necessary, and I can't wait to see you in the next one.